pushing through?
Yes, yes. And the vortexes are turbulence that are a function of how fast the water's moving. So yeah, these are like fossil features in the rock.
How fast did that?
Oh, probably 20 to 30 miles an hour, something like that. And it may have been flowing brim full, actually.
How fast is that water going?
Oh, 3 or 4 miles an hour, if that. But see what happens? Look, here's a little lesson in hydrology. You see how as the water comes and it goes through that constriction, how it speeds up? Because basically what's happening is if you measure the water flow, say right up there, where it's about 8, 10 feet wide, and then you measure the water flow here, you'll have the same cubic feet per second moving through each point because of the conservation of energy properties of flowing water. And so what that means then is that when water gets to a constriction like here, it has to speed up. When water speeds up, it becomes more erosive because the erosive potential of moving water is a function of its velocity. So next spring, when we all reconvene up in the Channel Scablands in eastern Washington, you will see some examples of this that are on a macro scale, mega scale. You know, these walls are what, 60 to 70 feet high probably, maybe 80 feet. But we'll stand in canyons that are 800 to 1,000 feet deep and a mile wide. And in some of them there are potholes just like this, except the potholes are 6 and 8 feet wide and 10 or 12 or 15 feet deep. And there are potholes up on the St. Croix River I used to go to as a kid that were up to 20 feet wide and 80 feet deep. So you know that that was some serious turbulence.
Is that when you see those ones where it looks like the I don't know what they call them, but it's these huge holes in the
Right in rock?
No, in water, and you can see the huge holes going down. Is that what you're talking about?
Yes, but on a much more intense scale.
Like how big?
Well, typically for these potholes here, the water was probably almost brim full through the canyon.
What at the top of the vortex?
Well, the top of the vortex, you could figure that the top of the vortex is probably going to be about 6, 8, or 10 times as wide as the pothole it's drilling. So this might have been a vortex, by the time you're at the top of the water, you would have seen a whirlpool that was maybe 15 feet wide, like this. And if you were able to see it underwater, you'd see that it's spinning and it's picked up rocks. And that rock, at the same time, it's also creating, just like a tornado creates upward suction, so does a water vortex will create upward suction. And so it's spinning and grinding the bedrock and then sucking that material up, just like a tornado would pull material up.
But I've seen things go down the vortex.
Well, that could happen too. I mean, because when it's wide, the water is going like this, and it's going down, but then at the same bottom, see what is happening, it's creating there's an area of negative pressure, just like in a tornado. You see the tornado is spinning, but inside the tornado, it's negative pressure. So that negative pressure is like creating a huge suction at the bottom of the vortex. Thank you.